This short video will present the top 3 cloud video applications for edge encoding and storage. Video encoding and storage infrastructure has traditionally been operating in central locations. However, cloud video trends are increasingly pushing encoding and storage infrastructure build-out to thousands of smaller, compact edge data center locations. One of the top applications is video streaming, where the video is captured at the source and then distributed to many thousands of consumers using a variety of devices using adaptive bitrate streaming. Now, for ABR streaming to work properly, you will first need to encode the video content into multiple versions of increasing resolutions and bit rates, what are sometimes known as encoding ladders. Now, traditionally, encoding ladders would be built in these central data center locations, but then the distribution of the full encoding ladders would have to be done along these core network links, which can get quite expensive on a month-by-month basis. So instead, the trend that we are seeing is the distribution of encoding ladder generation much closer to the ABR streaming servers in the edge data centers to minimize video streaming bandwidth along these core network links. The second application is video surveillance, which is increasingly moving into cloud video surveillance services. In this case, the primary video flows are moving the opposite direction, starting at each camera, flowing through the edge data center locations, and then for transport to the central monitoring station. Now, for cloud video surveillance, decoding the video camera feeds, processing, and storage inside distributed edge data center locations can reduce the bandwidth requirements and distribution costs along these links. For example, using AI processing of decoded video at the edge data center location, you can then determine and send smaller low bandwidth metadata bursts to the centralized monitoring teams to detect motion, recognize faces, or match license plate numbers, rather than the full distribution of the bandwidth along these expensive core network links. When an incident is actually detected that needs further analysis by a surveillance professional, only then would that request be made back to the edge data center to retrieve that archived video. The third application would be interactive video, such as cloud gaming, augmented reality, or virtual reality. Consider the low latency processing required for these interactive applications, starting with a game controller or a VR headset movement command sent into the cloud. The cloud gaming server then processes and renders each player's movement in a virtual game space. High-performance video processing resources would then rapidly encode and compress the next video frame for each player before sending that next frame back along the Edge or 5G network to the gamer's network device. Now, performing this processing in a central data center location would add network latency along these long connection paths. Instead, by applying game rendering and video encoding inside edge data centers, network delays are minimized to economically achieve cloud gaming low latency objectives. The Codensity T408 video transcoder is a compact, high-density, low-power video processing solution for edge data center environments. For video streaming applications, the T408 can encode or generate encoding ladders to stream optimal video resolution and bitrate based on device or network conditions. For video surveillance, the T408 can decode the video streams, allowing third-party applications to analyze the surveillance video in the edge data center location and then send low bandwidth metadata streams to the monitoring centers. And finally, for interactive video, the Codensity T408 would work side by side with the gaming servers in the edge data center locations to rapidly encode each video frame generated by the gaming server for transmission back to the interactive video devices. NETINT Technologies also offers the Codensity Edge Fusion E408, which combines video processing with SSD storage in the same compact device. Edge Fusion is beneficial for VOD streaming applications where video content needs to be cached close to the consumers. For video surveillance, the E408 can archive the surveillance footage at the edge location, saving core network bandwidth requirements and costs. And finally, in an interactive video application, the high-performance SSD combined with the video processing provides the foundation for powerful, low-latency interactive gaming video processing and storage for edge data center locations. For more information about netted transcoding and storage solutions for edge data center locations, please visit our website.